The fastest computer science students aren't smarter, they don't have perfect memories, they simply learn differently. While everyone else memorize code, they understand how everything connects, and once you learn their system, computer science starts feeling almost unfairly easy. Here's the biggest mistake almost every beginner makes. They believe computer science is about memorizing syntax, memorizing definitions, memorizing algorithms. But that's exactly why most students stay stuck. Want to know what the fastest computer science students do instead? They don't memorize. They build a mental map. Every new concept connects to something they already know. That's why learning gets faster instead of harder. Think of computer science like learning a city. You could memorize every single street, or you could simply learn the map. Computer science works exactly the same way. Build the map first and every new topic has a place to belong. So what should be the very first thing you learn? Not Python, not Java, not C++. You start with something far more important. Learn how to think like a programmer, and every programming language becomes just another way to express your ideas. Think about it. Languages change, logic doesn't. Python, Java, C++, they're all speaking the same ideas. Master the thinking, and learning a new language takes weeks instead of months. So where does programming actually begin? It starts with solving problems. Every app, every website, every game exists because someone solved a problem. Code isn't the goal. Code is simply the tool. Now here's the habit that changes everything. Before writing a single line of code, ask yourself, what exactly am I trying to solve? If you can't explain the problem, you'll never write a great solution. Now let's build the foundation of every program ever written. Every program, no matter how advanced, starts with input. The computer takes that information and processes it. And finally it produces an output. That's it. Input, process, output. Think about YouTube. You tap a video. That's the input. The app finds the video, loads it and prepares it to play. Then the video appears on your screen. That's the output. Congratulations. You just understood how millions of programs work. But here's where most beginners get completely lost. They hear the word variable and immediately think it's complicated, but it's actually one of the simplest ideas in computer science. Think of a variable as nothing more than a labeled storage box. Need to remember someone's name? Put it inside a variable. Need to remember a player's score? That's another variable. Programs don't have memory like humans, so they use variables to remember information. Now imagine you didn't have variables. Every time you needed information, you'd have to find it again. That would make every program painfully slow. So instead, the computer stores information inside variables and instantly finds it whenever it's needed. But variables don't just store information. They can also change. That's exactly why they're called variables, because the value can change while the label stays the same. Now, if variables store information, who decides what happens to that information? The answer is functions. Functions are the workers that take information, do something with it, and return the result. Imagine ordering a pizza. You tell the chef what you want. The chef does all the work inside the kitchen. A few minutes later, you get exactly what you asked for. That's a function. Functions aren't just useful, they're everywhere. Every time you click a button, some function starts running behind the scenes. That's why programmers break huge problems into small reusable functions. But here's another question: how does a program make decisions? How does Netflix know what to recommend? How does YouTube know which video to show next? The answer is something called conditions. Think about a traffic light. If the light is green, you walk. If it's red, you stop. Congratulations. You just used an if statement. If green, walk. Otherwise, wait. Programs make thousands of decisions every second. Can the user log in? Is there enough money to complete the purchase? Every app you use is constantly asking tiny questions and choosing what happens next. But there's one more superpower every program needs. Doing something once is easy, but what if you need to do it 1,000 times? That's exactly why programmers invented loops. Imagine you own a candy factory. Would you fill every single box by hand? Of course not. You build one machine that repeats the same task over and over again. That's a loop. Think about scrolling through your photo gallery. The app doesn't load every photo one by one. It uses a loop to repeat the same action. Next photo, next photo, next photo, until there are no photos left. Now something incredible starts to happen. You realize these aren't separate topics. They're all connected. And that's the moment computer science stops feeling like memorization and starts feeling like understanding. But here's the question: if everything connects, how do you remember it all? Most students try to memorize every single detail. And that's exactly why they forget almost everything. The fastest learners don't memorize facts. They memorize connections. Imagine building with Lego. Would you memorize every brick? Or would you learn how they fit together? Computer science works exactly the same way. Master the building blocks and you can build almost anything. So how do top computer science students learn so quickly? They don't study for more hours. They study with more purpose. They ask one question over and over again: how does this connect to what I already know? Let's test this idea. Imagine today you learn arrays. Don't treat it as a completely new idea. Instead, ask yourself, isn't an array just many variables organized together? And that's the secret. Everything builds on something else. Variables lead to arrays. Arrays work beautifully with loops, and loops often use conditions to know when to stop. Notice what's happening. You're no longer learning isolated topics. You're building one giant mental model. And once that model exists, every new computer science topic becomes easier to understand. But there's one habit that separates good students from exceptional ones. They don't just watch tutorials. They build small projects. Because computer science isn't learned by watching. It's learned by building. Think about learning to ride a bicycle. You could read 10 books, you could watch 100 videos, but until you actually start pedaling, you'll never learn to ride. Programming works the same way. So what should your first projects actually be? Not social media, not artificial intelligence. Start ridiculously small. A calculator, a to-do list, a number-guessing game. Small projects teach big ideas. And here's another mistake almost everyone makes. They rush to the hardest topics without mastering the fundamentals. The strongest programmers aren't the ones who know the most. They're the ones who understand the basics the deepest. So what should your daily study routine actually look like? Not 6 hours of non-stop studying. Study one concept at a time. Understand it. Build something with it. Then connect it to everything you've already learned. And then do something most students skip. Teach what you just learned. If you can't explain it simply, then you probably don't understand it as well as you think. But there's one enemy every computer science student must defeat: forgetting. You understand everything today, and next week it feels brand new again. That's normal. Your brain deletes what you don't use. So how do you remember for years? The answer isn't reading again. It's using what you learned. Every time you build, you strengthen the connections inside your brain. But here's the biggest mistake that keeps students stuck for years. They keep starting over. New language, new tutorial, new course. But mastery doesn't come from constantly starting over. It comes from going deeper. Imagine learning to play the piano. You wouldn't practice a different instrument every single day. You'd master one instrument first. Programming works exactly the same way. Go deeper before you go wider. So what does the perfect computer science roadmap actually look like? First, learn problem solving. Then master the fundamentals. Only then move on to data structures, algorithms, databases, and everything else. And here's the beautiful part. You don't have to know everything. You only need to understand the next piece. One connection every day. That's how experts are built. Now let me tell you something that changed the way I learned forever. I stopped asking how much did I study today. I started asking what did I actually understand? And that's when everything started to click. So if you remember only one thing from this video, don't chase more information. Build better connections. Because that's how computer science finally starts making sense. So the next time you sit down to study, don't ask what chapter should I memorize? Ask, how does this connect to what I already know? That single question will change the way you learn forever. Computer science isn't about having a perfect memory. It's about building a stronger way of thinking. The better you're thinking, the faster you're learning. And that's the real shortcut that almost nobody talks about. If this video changed the way you think about learning, hit the like button so more students can discover this learning system. Subscribe, because we break down complex ideas into simple ones.